Welcome to the Crazy Hat Chemist, so another video in atomic structure and electron configuration. So let's get moving. BAM! Today we're doing the electron configuration, orbital box diagram, and set of quantum numbers for gold. That's atomic number 79. So Z of 79 means it is the atomic number of 79. There are 79 protons. There's a 79 electrons, and that's what we're most interested in. We are looking at gold. There's gold. I don't know if you can see that right there, but there's gold right there on my periodic table. So I'm going to use the noble gas notation of gold. You need a periodic table, noble gas notation of gold, and then this is what it is. So it's xenon in brackets, 6s2, 5d9, 4f14. Okay, so how many valence electrons in gold? Like anything inside the boot, that's a D or an F type orbital ending in, if you will. Okay, and it is 2. So 2 valence electrons. Why? Here's another way to do it. What's the largest principal quantum number here in gold? 6. Okay, are there 6 S's and 6 P's? There are no 6 P's, so I don't have to worry about that. Put that off to the side because they're not there. There are 6 S's. How many electrons in the 6s? 2. How many valence electrons? 2. Same thing. Okay, I'm going to do the orbital box diagram of gold now as well. So here is the orbital box diagram of gold. So I've got that organized according to the electron configuration, same organization, same order. That is the 6s, the 5d, the 4f. Hopefully that works for you. So let's place these electrons as they are placed as you walk them through the element to find that element. So 6s2, hopefully you got that part. Then there's a 5d1. Now after the 5d1, what are we going to start filling in? The rest of the 5ds, the answer is no! We're going to fill in the 4f's. So I've got to fill in those 4f's first before I get to the 5d2. So all these are filled in here for the 4f's. So the 4f's are completely filled. I did them in the order. That is half-filled orbitals first and then backfilling them. Okay, now I'm going to go and finish up the 5d. Now look where gold is on the periodic table. You should have found it already. So I'm going to have a 5d9. I have 5d1 already. Here's 5d2. Okay, 3, 4, 5. Then starting to backfill 6, 7, 8, and 9. Okay, so is gold paramagnetic or diamagnetic? So this is the orbital box diagram of gold right there before you. And from the orbital box diagram, we can determine paramagnetism or diamagnetism. Remember, paramagnetism has at least one unpaired electron, if not more. Diamagnetism has all completely paired electrons. So gold is paramagnetic because there's one unpaired electron, and that is in that 5d in that last box. Okay, in the M sub L of 2. All right. Hopefully you looked at that really carefully there, and then you should be scratching your head thinking, Okay, so I'm going to come back to that. So I'm going to circle an electron, and you're going to get a set of 4 quantum numbers. That's N, L, M sub L, M sub S of that particular electron. So that's what I want you to do. I want you to get a set of 4 quantum numbers to represent that electron right there, then restart the video. So here we are. So N is 5 because it's a 5D. Therefore, it's N of 5. Okay, it's a D type of orbital. So what's the number designation for a D? Remember, the S's are 0, the P's are 1, the D's are 2. So it's an L of 2. Okay, now the M sub L value is the orientation along the 3D plane, XYZ axis. So you're going to label the boxes. The middle box is a 0. Then to the left of that is -1, -2. To the right of the 0 is +1, +2. Which box is this in? It's in the +1 box. So it's the M sub L of +1. Then that arrow is downward facing. So that downward facing arrow, okay, is going to hell, and that is negative. So the M sub S is -1/2. So here are the set of 4 quantum numbers to represent that single electron that has been circled, which is N of 5, L of 2, M sub L of 1, and M sub S of -1/2. Now, I want you to notice something, that this particular set of 4 quantum numbers that we did was the last electron in gold. Now, you could have looked at the periodic table and looked at a previous video in which I did, and you could have gotten the electron configuration and then the set of 4 quantum numbers to represent gold based on its location on the periodic table. I want you to try to do that. Okay? All right. Now, look at gold, look where it is on the periodic table, and think to yourself, have we done copper's electron configuration? Yes, we have. We haven't done silver's, but copper, silver, and gold share something in common. And that is, this is the predicted electron configuration, which differs from the actual electron configuration. So what I want you to do is look at gold's predicted electron configuration and copper's predicted electron configuration and figure out how you solve this and make this into the actual electron configuration. Okay, so what's happening is that 6s2 for gold is one of those electrons is going to drop down into the 5d9 to completely fill up the 5d9 and make it a 5d10 and then have a 6s1. And that's what we're going to have right there, like that. So it's going to be 6s1, 5d10, 4f14, because that 5d orbital is interior that of the 6s, which is outside. And having a completely filled interior orbital is lower in energy than having it almost completely filled and having 2 electrons on the outside. That doesn't make sense. Okay, so notice that I've circled that. This is the actual electron configuration for gold. Copper and silver follow the same exact pattern. I've already gone over that of copper and mentioned silver and gold previously, but I wanted to do gold again. Okay, so a completely filled subshell is lower n is lower in energy than filling a larger n value. So make sure that you note that. Your professor or instructor might enjoy those. We already did tungsten just a while, so this chromium column as well as the copper column both share this similar pattern. One of them is going to be half filled, the other one is going to be completely filled D subshell. Okay, so make sure that you know that. Okay, I am the Crazy Hat Chemist, and of course I gotta end with a crazy hat. There's no bull about this one. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. I'd greatly appreciate that. Have a delightful day and study your chemistry. Wait to watch more cool chemistry videos. Click on the next one. It's going to be a fun one. See you next time. Bye now.